So today we are doing, it'll be chapter 6, it'll be the proportions, linear models, and functions. We're going to be demonstrating the understanding of ratios and proportions, the use and interpret of the function notation. We're going to solve problems using the linear models, and we're going to be solving proportions. That is my learning objectives. Let's go ahead and look at my first example. The first example, this is proportion, linear models, and functions. We're going to be doing this is a function table with two-step rules. We're going to fill in the table using this function rule. So what you need to do is you take each one of these x's and you plug it in for x and you solve for y. Example 1. So we have a y equals 5, and we're going to substitute that in the 2, right? 2 minus 3. So what is 5 times the 2 minus 3? 7, yes. Not a trick question. So you put a 7 here. Now we're going to do for if x is equal to 5. So we have a y equals 5 times the 5 minus 3. So what is 5 times 5 minus 3? 22, yes. You must multiply first, then you subtract. Remember order of operations? Please excuse my dear Aunt Sally. Okay, let's do the 6. So y equals 5 times the 6 minus the 3. As you see here, I'm just putting in the x, the value of x, and I'm solving for y. So if I have y equals 5 times 6 minus 3, what do I get? 27, yes. So you put 27 here. Let's do one with the 8. So y equals 5 times the 8 minus 3. So what is 5 times the 8 minus 3?
37.
37, good job. Questions over that example? I think it's pretty straightforward. All you do is you take your x's, you plug it in for x, you solve for y. You guys got that down? Okay. Let's go to the next one. The next one is ratios. When we talk about ratio is of A to B, which can be written in these 3 forms. You have an A over B, kind of like a fraction. Then you have an A to a B, and you have an A colon B. So that's 3 ways of writing it. In example 2, write the following ratio using 2 of the other notations. So we have a 3 to 1. Example 2. I'm going to have to move it so they can see. Yeah, that's better. So what is one of the notations we can use? We have a 3 to 1, so what is another one I can use? So if I used the 3 colon 1, what is another notation I could use?
3 over 1.
3 to 1, or a 3 over 1, right? a while.
I know. I need to start cooking.
Okay.
I have a lot of stuff going on, so.
Okay. Well, as long as you can get caught up,
Right.
we're good.
I was late today because I was in the shower. I wasn't paying attention to time.
Let's go to example 3 here. We're going to be writing a ratio for real world situations. Example 3, we have 9 roses and 8 daisies in a vase. Example 3. Let's look at A here. A, what is the ratio of all the flowers in the vase to daisies? So all the flowers is how many? How many flowers do we have altogether?
17.
17. And how many daisies?
8.
8. You can write like this, or you can write 17 to 8, or you can put 17 over 8. But you can't put all 3. You just put one of them. Let's go to B part. What is the ratio of all the flowers in the vase to roses?
17 to 9.
17 to 9, good job. Or you can put 17 to 9, or you can put 17 to 9. Questions over that, writing ratios? You probably may have even done this in school. Maybe in middle school or high school. So the next one, this is the definition of a proportion. A proportion is a statement of equality between two ratios. To solve a proportion, we solve it by cross multiplication. So as you see here, I was saying about cross multiplication. So if A over B equals C over D, then AD equals BC. So I just going to cross multiply. I don't know about you, but I can't really see you guys can see the proportion, right?
Yeah.
Okay. Anybody need a minute to write this down?
Thanks.
Okay. You gotta slow Miss Jackson down because I'm about ready to fly. Anybody need another minute? Okay. So let's go to the next example. We got example 4. So we're going to be solving a proportion of the form x over a equals bc. So this is going to be basic. So example 4, it's right over here. It is a w over 9 equals to a 2 over 6. Now the way I like to explain it is, and I do this just to help you guys out, to help memorize. I call this the butterfly effect. What do you mean by that, Miss Jackson? Well, what I mean is, let's look at the blue wing, then we're going to look at the green wing. Okay. So let's look at the blue wing there. What is 6 times W? 6W. Now what is 2 times 9?
18.
18. Now we need to solve for W, so what do we need to do?
Divide.
By 6. So W equals, what is 18 divided by 6?
3.
3. So your answer's 3. You guys like that butterfly effect? It's cross multiply or butterfly effect, whatever works for you. I do that so that when you go to take your test, you can remember. Okay, let's look at the next example here. This is example 5. So we're going to be solving a proportion in the form of where you have an x plus a over b equals c over d. So I'm going to erase this. I'm hoping you guys got that. Example 5. Example 5. I have an x plus 4 all over 12 equals to a 5 over 8. Okay. How to get my wings ready there. The butterfly effect. So, okay, let's go ahead and multiply. See, I got the red and blue. So let's go ahead and multiply on the red. So what is 8 times x plus 4? I'm just going to put down 8x plus 4 equals to 12 times 5 is what?
60.
60. So what did we do to this 8? What property did we use? We use what? Distributive, remember? So what is 8 times x? 8x. What's 8 times 4?
30, no,
Yes.
32.
32, yes. We still need to solve for x, so what do we need to do to the 32? What do we do to the 32?
Wouldn't you just add 8?
Subtract, yes. If it helps, cancel that out. 8x equals to, what is 60 minus 32 is what? 28. Still need to get x by itself, so what do we need to do?
I feel like you divide that.
You divide, correct. So, 28 divided by 3 is 3.5, I believe. You can check it on your calculator. Well, I believe I'm right. So do you guys like that butterfly effect? It helps. And the reason I have it circled in different colors is so that you can see which one goes with which. Now the next thing is we're going to be, this is the procedure on how we solve applications using proportions. So we're going to represent the unknown by a variable. Then we're going to set up the proportion by listing the given proportion on the right side of the equal sign and the unknown and the other given quantity on the right side. Note, setting it up on the right side of the proportion must be in the same respect, quantities on the same position on the left and right. So for example, what I mean is like, if I had miles to hours is equal to miles to hours. You can't say miles to hours equals hours to miles. No, it has to be the same, right? Otherwise they wouldn't be equal. I did this to one class and they said, what is your point there? And I said, because I'm applying this to the problem. That's my point. So once we have the proportion is correctly written, use cross multiplication, and then we solve. You guys want a moment to write that down? While you guys are doing that, I'm going to erase. I hope this makes sense. Does this make sense? What I'm trying to say? Okay. You guys need another minute? Okay. Also want to ask you guys, are you guys able to see Brightspace? Yes. Okay, good.
Like, we're using Brightspace now.
Yes. And I've also been trying to post my presentations, which I do, these are my PowerPoints. I've been trying to post them, didn't know if you guys have been looking at them. And also, I've been posting, when I record myself, I've been trying to post it. I think I'm up to date until now.
Wait, do we have assignments on Brightspace?
No,
Okay.
your assignments is Alex.
Okay. I was gonna say, I don't
No,
know.
no, mine is just words that you read, and if you want to,
Yeah, I'll use Brightspace for those ones.
I just use it for, pretty much, for your information. You wanna know what grades you got in here, or what's going on in each week, my PowerPoint presentations, and my, my recordings of me teaching. No, I don't give assignments, no Alex.
Right.
So if you're behind on Alex, or you left something out, then that's your assignment. You should say, email me and say, hey, Miss Jackson, can you give me extension? Otherwise, I'll give you a 0.
I think I
You
need
don't
to-
reach out to me, I say, okay.
I'll email you later.
Okay. Also, I'm going to be giving you guys also, I didn't know, I'm sure you know by now that I've been giving you guys 2 chances on taking your test. And this last one, I didn't know if you noticed, when you took your second attempt, you only correct the ones you miss. So you only get better, you don't get worse. Even when you did take it the second time, I kept the best score, so you didn't get worse. I think it would be wrong if I kept the worst score. Right?
Yeah.
Yeah, I don't want people to fail when I pass. But you gotta work for me. I don't give A's, you earn them. So if anybody tells you, Miss Jackson, she gave me an A. No, you earned it. But if you don't work for me, then I gave you, because you earned it too. Okay, moving on to, this is a word problem on probabilities, type 1. So I've had a lot of people come to me and say, Miss Jackson, the problem I have is with word problems. So what you have to do is you kind of have to decipher what information you need to figure out how to set it up. So let's look here, example 6. Here, there is a sales tax of $12 on an item that costs $126 before tax. Now the second item costs $105 before tax. What is the sales tax on the second item? So I'm going to put sales tax over the cost, right, equals sales tax over cost. Right, you agree with that? Sales tax over cost equals sales tax over cost. That makes sense to me. So in that first sentence there, a sales tax of 12. So where am I going to put that 12?
On the top.
On the top. Good job. One of them. Where am I going to put the 126?
On the bottom.
On the bottom. Equals something. Then the second sentence is, a second item costs $105. Where am I going to put that?
On the bottom.
On the bottom. And what do I put on top? X. Or we can call it S for sales tax. It doesn't matter, it's just a variable. One of my other students said, what is X? I said, X is unknown until we find it in this problem. Okay, so we're going to do let's do the butterfly effect here. That's some green. That looks pretty good. Let's do orange this time. There we go. Got it. Okay, so it doesn't matter which one you do as long as you keep your wings So let's do the orange. So what is 126 times x?
126x.
126x equals to, and then we have a 12 times a 105, right? Because that's the green wing. 126x. What is 12 times 105?
1260.
It's what?
1260.
1260. Okay? Still need to solve for x, so what do we need to do? Divide what?
126.
126. I had another student was trying to divide the 1260 by that, and I said that would equal 1. I said that didn't get x by itself. I was like, I thought, huh? We're trying to get solve for x. Okay, so 1260 divided by 126 is 10, I believe. You can check
Yes.
my calculations. I did it in my head, yeah. Okay, so this is sales tax. Sales tax, right? Questions on that?
I feel like this is the only thing I've done all through high school.
In high school, they emphasize algebra, pre-algebra, algebra 1, algebra 2, and geometry. You never see sets. And they also emphasize in the algebra graphing, which we will start
I
on,
hate that.
we're starting on Monday.
Of course you're gonna say that.
Maybe you'll love it after I teach it.
Maybe.
Okay, let's do example 7 here. So this is a word problem on proportions. And you want to have one similar to this, probably exactly like this, just saying. Okay. So we have a petroleum motor oil is a combination of the natural oil and the synthetic oil. It contains 7 liters of the natural oil to every 5 liters of the synthetic oil. In the order to make 1,152 liters of petroleum oil, how many liters of natural oil are needed? So we're going to set up a proportion. Something equals something. Okay, so far so good. So we are looking for, what are we looking for? We're looking for natural oil, right? Someone put natural oil up here. Natural oil over here. Okay, that was good. And we need to do, we got petroleum. Petroleum, P-O-L-Y-M, oil, petroleum. Okay. So, let's go to that first sentence again. So, petroleum oil is a combination. What does it mean to be a combination? So, you're going to mix them, right? You're going to mix them together. Of natural oil and synthetic oil. Okay, got that? So, there's 7 liters of natural oil. So, we have to do something with the 7. So, let's put it right where the natural oil is, right? To every 5 liters. So, if I have 7 liters of natural oil and 5 liters of synthetic oil, how much is that together to make petroleum?
13.
12.
Oh,
Yeah. So we put 12 here, right? Now go to the other side here. In order to make 1,152 of petroleum oil, where am I going to put that in the graph?
On the bottom.
On the bottom. 1152, right? How many liters of natural oil are needed? So what am I going to put? I'm going to put X. So the other class said, Miss Jackson, how'd you get that 12? Where'd it come from? Well, if you remember, it was a combination of them, so I added those two, right? To make the petroleum. So let me draw my little butterfly effect here. Doesn't matter what color you use, but I just like to use different colors because there we go. Okay. Looks good. So let's look at the red wing here. So what is 12 times x?
12x.
12x. And 7 times the 1152.
8064.
8064. That sounds right. I'm taking your word. So we still need to solve for x. So what do we need to do? Divide by 12. Divide by 12. And x equals what?
672.
672. 672 what? Liters
Liters.
of natural oil. Yeah, that looks better. Otherwise it said liters natural oil. Let's be up there, makes sense. Sometimes I have to, even on English, I have to reread what I wrote, and I'm like, does this make sense? Sometimes I accidentally leave out words. You guys ever do that?
You know what?
I left out words.
Yeah.
I'll do it all
Because
the
I'm like
time.
saying it in my head, but
Yes.
I'm not typing it.
I say it in my head, then I type, and then I read it, and I say, that's not really what I meant. It's kind of what I meant, but not totally. I had to do that a lot when I was turning papers. Then I still messed out, left out some words. That's part of the reason I made a B in it, not an A. Okay, so let's look at example 8. So this time we're going to be writing and evaluating a function. So remember, a function is an equation, okay, that models a real world situation. So we got Hans. He needs to read 3 novels each month. Let N be the number of novels that Hans needs to read in M months. Write the equation relating to N to M. Then use this equation to find the number of novels that Hans needs to read in 17 months. So what are we going to do here? Example 8. So we have an equation here. We have an equation, dot, dot. And the number of novels in 17 months. Okay, so let's come up with an equation. Anybody have an idea? Let M be the
My problem is
number.
always writing the equations. I can solve it as much as you want me to, but when it tells me to write one,
That's where,
that's where I struggle.
that's what the other class did too. The other class could tell me this, but then I asked them for this, and I said, this is on your Alex, so you're gonna get, and it won't let you go on if you just give half of it. So if you can do this, then how did you get this? What'd you do? Not sure?
So,
Okay. Let's read it. So if he has to read 3 novels each month, what are we gonna let M be? M's gonna be my month because it stands with M, right? And let N, see it says it here, let N be the number of novels, right? So why can't we say novels, numbers equals to how many months? 3 months, right? 3 months, remember? So the first month he reads 3. Second month he reads 6. Next one he reads 9. You see that? Every month he reads 3 novels. Right, so you're adding on 3 times the 3 for each month. That make sense?
And then he'll read how many novels in 17?
Yes. How many will he read? So you take the 17, plug it into M, and what is in? 51, yes. Does that make sense?
Yeah.
I still believe it takes practice. But I believe coming up with the equation is the hardest part. The other class told me what this was, but then had trouble making this. I said,
That's how I am.
but I said you have to get both to get credit, even on Alex, you know.
It's just like easy to read it and like solve it by reading it, if that makes sense.
Yes. They made sense of it down here, and I agree. But then I said, give me that equation that you came up with to get this. They went, didn't say anything to me. But does that make sense on how I got that? Next example, we're going to be interpreting the parameters of a linear function that models a real-world situation. So let's let y represent the total number of publishing. Oh, I've got to erase this. That's much better. I applied to last equation. So let y represent the total cost of publishing a book in dollars. Let x represent the number of copies of the book printed. Suppose that x and y are related in the equation. So they gave us an equation, you'll see. I really don't think it's supposed to have that equal there. Yeah, it's better. What is the change in the total cost for each book printed? So what is the change? So I'm going to let you guys know this. You might want to make a note in your little notes. The change is the coefficient to the x. So what would that be here?
10.
10. What is the cost to get started before any books is printed? So if I let this be 0, what would it be? If I let this be 0.
10.
I let anything times 0 is 0.
0.
You would just get this. 450. So in this example, so even if there were 0 copies of the book printed, they would still make $12.50, even though no books were published. But you see, you make more money for every book you publish. Don't you agree? For one, you go up 10, so it'll be, what, $12.60? That you publish 2 books, that would be $2.70. Another book, $12.80, $12.90. You guys see what I'm getting? So for the change, it's just going to be the coefficient of x. And also the cost for just to get started will be this. Questions? Okay. Let me erase that off. Anybody need a minute to write this down? The next thing we're going to do, we're going to be doing similar to what we did earlier. Do you remember in the first class we was doing the table for the linear function? So does anybody know or remember what is the fancy word for saying f of x? What's a fancy word for saying f of x? I mean, what's the not fancy word? What's the simple word for saying the f of x? It is just y. Okay?
Oh, I don't know that.
You didn't know that? So you think of that as y. So all you have to do is we're going to take each one of these and we plug it into x and it'll give me f of x. You guys remember that first part of the class? I'm going to erase this. This is example 10.
Example 10.
So let's look at -2. So that would be, really you write f of -2 equals to 3 times the -2 plus 4. Do you see how I got that? I just substitute, I took this right here. Everywhere I seen that x, I put an x there, and I put an x there. Equals. So on this side, what is a 3 times the -2 plus 4?
3 times negative 10.
Would be what?
Negative 10.
Think about it. 3 times the -2 is, positive times is -6. -6 plus 4?
Oh, 2.
-2, yes. So you put -2 there. Let's go to 0, so we put f of 0 equals to 3 times 0 plus 4. What is 3 times 0 plus 4?
4.
4. 4. Let's do the 1. Y'all see what I'm doing here?
Seven.
7, yes. Let's do the 4.
16.
16, yes. And what if I have a f of 5? F of 5 equals 3 times 5 plus 4. You see, you guys already got the answer before I even done writing that problem now. That's good. When you guys are good, you're good. 19. You see I'm getting those answers. Then you click check. And say correct. Questions? You guys are okay?
So far, so good.
Let's go to the next one. Okay, we're going to do example 11. This time we're going to be evaluating functions, and pretty much what we did in the last one we just did, we evaluated functions on the function rule. Evaluating function linear and quadratic or cubic. So if I have, let's erase those so I don't confuse you.
Too late.
Okay, if I have functions f and g are defined as followed. So if I have f of -6, am I going to use the f function or the g function? Which one am I going to use? If I have f of -6, which one am I going to use of the functions? The f, yes. So we put f of -6 equals 5 times -6 plus 4. Okay? What is 5 times -6 plus 4?
26, negative 26.
-26. So you put -26 in there, what I asked you. What if I have, so if I have g of -3, do I use the f function or the g function?
G function.
G function, yes. Gotta match it up there. So it's a -3 equals to 2 times the -3 cubed plus 2. So you gotta remember order of operation. You guys remember order of operation? Please excuse me, dear Aunt Sally. So what do we do first? We need to do parentheses, which is our exponent. So what does it mean, -3 to the third power? What does -3 to the third power mean?
Negative 27.
It's what?
Negative 27.
What does it mean though? It means -3 times -3 times -3.
Oh, I just gave you the answer.
That's okay. The other class said, why is it at -9? And I said, because it's -3 times -3 is what, 9? Times it by another -3 and you get a -27, that's why. Oh, let's see. I was like, you don't times this to this. I said, this is an exponent and you take the base that many times. I guess they forgot their exponents. So that was okay. I straightened them out. So what is 2 times a -27 plus 2?
-25.
This would be, what is this right here first of all? Negative what?
Oh, I didn't do that part.
50, what is it, 54? Right? Is that right?
Mm-hmm.
Just checking.
Yeah.
Making question my own work here. What is a -54 plus 2?
Negative
52.
-52. Questions on those? We evaluated functions. And this is linear because it just has the exponent of 1, and this is cubic because it has the exponent of 3. Didn't know if you guys knew that.
Hold on just a second.
Amanda, I'm glad you slowed me down, so I'm ready to roll on.
Yeah, we may have to start just rolling with the slow buttons.
Yeah, next week I'm bringing in my big graphing, so I can show you guys how to graph.
I'm decent at solving whatever problem it gives me, like with algebra and stuff, but it's still writing the problem. It doesn't matter how long I have took algebra, and writing the problem has always been.
What do you mean, like writing an equation?
Yeah. And then I'm stuck, I can't write the equation.
Well, you have to sit there and think. Okay. Here we go. Let's look at this one. Let's look at example 12. This time we are going to be finding the output of a one-step function that models a real-world situation and function notation. So Michael earns $55 per week for working part-time at a bookstore. He makes $1 more for every book that he sells. The amount A in dollars that Michael earns in a week if he sells B books in given the following function. So we have they give us the function. The question is, so how much does Michael earn in a week if he sells 22 books? What are we going to do there? This is example 12.
Would it be 55, like, 55 plus 22?
Yes. Good job. And this is 22, which would be 55 plus 22,
Yes.
which would be what?
Oh,
You should have to use a calculator.
you have to.
What's 5 plus 2 and 5 plus 2?
77.
77. 77 what? $77, right? That's what he makes for selling 22 books, right? Yeah. Hold on a minute, let me get that calculator. Sometimes I think we get a little bit too dependent on it, which I don't mind using calculator in my class, just saying. Sometimes I think you need to use a little mental math, just saying. I even do that to my sons. I'll pop off questions and I'll say, what's this, or what's this to take away this, or what's this time this, and he said, Mom, haven't you had enough math at college? And I said, no. Just like my shirt. I don't know if you guys, did you guys read my shirt today?
I love
Portner.
Important, yes. So one student told me, he said, but Miss Jackson, math, you're supposed to correct them. They said math is important. I said, exactly, my thoughts. See? Okay, so we're going to 13 here. We're going to be finding the inputs and outputs of a two-step function that models a real-world situation. And this is a function notation. So we're going to be finding the input and output of the, pretty much what it says there, and it needs to find the real-world situation. So we have, they gives us this function, right? They gives it to us. Then we have to read down here on the A part. I'm gonna erase this so those students who are watching me can see it too. This is example 13.
I have to get back to it.
Okay. So we have C of N equals 7,500 plus 150 N. So look at part A. What is the total cost of transporting 14 tons? So what are we searching for? The total cost. What do you think is the total cost? Which variable? Is it the C of N or is it the N? What is the total cost of transporting 14 tons?
Would be the N.
It would be the C because it's cost, right? So we have C of 14 equals to 7,500 plus 150 times 14, right? Take one step at a time. What is 150 times 14?
2,100.
2,100. Now what is 7,500 plus 2,100? Come on, someone help me out here.
9,600.
9,600, there you go. So this is, since it's the cost, it is all those, right? So what is the total cost of transporting 14 tons? It's what? 9,600? That's the A part. Let's look at B part here. If the total cost is 11,250, how many tons is the company transporting? So what are we looking for? In part B, what are we looking for? Are we looking for C or are we looking for N?
N.
We're looking for N, yes. So we're going to substitute. We're going to substitute this in for the C, right? 1, 1. Okay. Equals to 750 plus 150 N. And why he says I don't confuse you. It's for another problem. Okay, now we need to solve for N, so what's the first thing we need to do here to solve for N? What do we do? See, I forget you guys are taking notes, I just want you guys to answer me. I guess because I know it. You know what I mean?
Would you add the 7,500 and 150?
You would subtract it, right? Yeah. Because we want to get rid of it on the right side. If it helps, cross it out, right? That leaves me with 150 N. So what is 11,250 minus 7,500? Let's see here, 0, 5.
3,750.
37?
What did it say?
That'd be 36? 35? 35.50?
I've done it 3 times.
You did, okay. Make sure. 5. I'm thinking, I don't know why I think that's like a 5 or something, like 35.
37.50.
Is what?
3750.
It is? Okay. Okay, now we need to divide by 150 both sides. And what does this equal? 25. 25 what?
Tons.
Tons. I try to make it make sense. You ever notice that about math when I try to teach it? I try to make it make sense. If your answer doesn't make sense, you probably did it wrong. You guys ever notice that when you go, what? Questions?